This is Radio TV Phononut, and here's a circa 1939 RCA Victor, little plastic-cased midget 5-tube radio. Not too bad. I like the design of the case and the fact that it has RCA Victor spelled down the side of the case. The case is in pretty good shape. It's got a crack here on top that looks like a heat stress crack. The audio output and rectifier tubes are close to it, and I've seen that happen before. Somebody's obviously worked on this. The power cord has been replaced, and I don't believe they had polarized line cords back then. The guy says it works beautifully. Let's plug it in and see if it does. Let's see if we get any smoke. Well, the volume control is turning, but well, okay, there you go. This is a pull-on off switch apparently instead of a turn switch like most radios have. Anything lighting up in the back? Yep. Dial bulb is slowly coming up. Well, I'm not getting no abundant supply of stations. All I'm getting is static. Alright, let's pull it apart and just see what's going on here. Looks like the chassis mounting screws are missing, and it looks like one of the studs is broken. So we'll have to fix that some sort of way. Now, I always cringe when I get radios like this that look like they've been worked on in recent years, because I never know what I'm going to find under the chassis. I have not pulled this out, so we'll pull it apart and we'll find out together. Alright, removing the chassis, I see some rubber wire that needs to be replaced, and this wire here could be a problem as to why we're not receiving anything. It looks like it's crumbling and falling apart, and it was touching the tuning condenser frame, so that could be a problem. Alright. Flip it up and see what we got under here. I got a feeling this is going to be hacked. Alright. I see some capacitors have been replaced at some point. What is this? Spragg atom. And what are these things here? These gray capacitors. They look like they've been around a while though, but it doesn't look to be severely hacked up, which is a good thing, but there's some rubber wire that's going to have to be replaced. Looking at these, I'm wondering if these are actually original equipment capacitors. I've seen some in RCAs of this vintage that looked similar on the ends, but they were brown in color, they weren't silver, and these solder connections don't look like anything recent, so these may very well be original equipment. Alright, I'm going to lift that shorting wire to the tuning condenser, and we're going to fire it back up again and see if it plays. Well, I'm already hearing more promising results.
Drum on this, by the way. If they made me czar of college football, everybody talking about Alabama, Clemson, how good they are, and how it, it kind of soaks up a lot of the oxygen in the atmosphere.
To prevent water from flooding your basement. And I really like Zoller's new Aquanaut Fit 508 battery backup system.
The speaker's got a rattle, but we'll fix that.
The primary pump can't keep up or power is interrupted. plus the Aquanaut Fit.
Okay, that's it.
It all leads off to the original PB Blaster, the #1 penetrant for breaking free rusted and stuck parts. There's silicone lubricant.
But that's not bad for emotionally original parts.
Don't bust your knuckles this summer. Bust your nuts with
everything you just said, Clay. The other thing that I would do, which I think is a little bit of a revolutionary idea.
Is that WDIA? Probably so.
From fighting wildfires with air support, helping civilians in flooded neighborhoods.
Okay. I always like to check the audio output stage, so checking the control grid voltage of the output tube in respect to cathode.
For my brother's the same way. Like whenever we go somewhere, his daughter, who's 15,
and that looks good.
has to bring
I'm not seeing a positive voltage. I'm seeing a negative voltage. That's what I want to see.
It is what it is. But when they get teenagers, they
So that tells me that coupling capacitor is not leaky.
the common question is
Getting about 65 volts. Well, that's 64. It's trying to hit 65 on the plate of the first audio tube. That's good.
That usually means they're actually
Getting about 93 on the plate of the output tube. That might be a tad low. It's acceptable, but it might be a little higher.
You probably put them in.
Went forward.
Let's look at string grid.
Sure than any catastrophes. Yeah,
About 98.
it took a
Look at
minute
the cathode.
and 18 seconds for this review.
About 6.
And I
That
just want
looks
to say
good.
I might be the only person in America.
Alright, for safety, I would like to change this capacitor here. This is the one that's across the AC line, and they have been known to short and blow shrapnel everywhere and cause other components to fail, so we'll get rid of this one anyway. Okay, this capacitor is an Aerolite by Aerovox. Don't think I've ever seen one of these before. And I do believe it was a replacement because one of the terminals came off too easy when I unsoldered it, and I don't think RCA would have just laid the terminal of the capacitor, the lead of the capacitor, over a tube socket and soldered it on. So, yeah, just for fun, let's analyze this with the old school capacitance meter and just see how it checks. Now, the old trusty Heath kit says 0.039. I know that's not the most accurate in the world, but I'm concerned with the leakage. And this is a 400 volt cap. And this cap is perfectly fine. No leakage at all. But given the circuit that it's in, I'm still going to replace it with a proper AC safety cap. Well, the light's flickering about every 20 seconds on 400 volts, so it's a little bit leaky. And the brand new capacitor is testing the same way, so I think that old one is perfectly fine. Okay, we're back on this radio after a several month break. I was looking back at the last footage that I saved for this radio, and that was back in August. And I swear it don't seem like it's been that long since we've been on this thing, but you know, the figures don't lie, so we're back on it. And where we left off was me changing the AC safety capacitor that's across the line. Going to have to replace a lot of rotten rubber wire in this set, unfortunately. Went ahead and patched the speaker for now, but if this one has to be changed, it won't be a big deal. It's a 4-inch speaker, and fortunately the audio output transformer is mounted to the chassis, not to the speaker itself. And if I have to replace this, the only thing I'll have to do is substitute about a 470 ohm 5 watt resistor for the speaker field coil. Now, as shown in the previous footage, someone has worked on this and recapped this some time back, probably in the 1960s. Well, let's put it this way. They could have recapped it a month before I got it using old parts, but this power cord is definitely newer than the 60s. But at any rate, we've got a lot of cleanup to do here. This spragg atom capacitor appears to still be good. And you know what? I'm probably just going to leave it in place. Probably going to leave all of these capacitors in place unless they give me a reason to replace them. The biggest thing I'm going to have to do is clean up the service work and replace some of this rotten rubber wire here. And then we ought to have a radio that's good to go. Okay, I'm checking this spragg atom dual filter capacitor. It's a standard 50-30 microfarad. And the 50 microfarad checks 45, which is within tolerance. And the 30 microfarad checks 32, which is in tolerance. And ESR-wise, about an ohm on that section, and about an ohm or a little less on that section. So this cap is fine. And you know what? I'm going to leave it just so I can make people cringe. I can hear them hollering and moaning now, but this cap's good. It's probably maybe better than some of the new caps you get. And since this is not a radio I'm planning on getting rid of, then if it goes out, then I'll just take it apart and change it. Okay, I've given up on it trying to focus, but this is a spragg vitamin Q capacitor, the coupling cap for the audio output tube, and those are top-notch capacitors. In fact, I could probably pull this out and sell it for what I paid for the whole radio, but I'm not going to. However, I am going to clean up where somebody installed it. They just had it laying on the tube socket terminal here, with pieces of the old capacitor lead in place and resistor, because they replaced this 470K resistor too. But I'm going to put it in correctly. I'm going to physically attach it to the tube socket pin and solder it, or solder both of them, I should say. Alright, here's pin 2 with a rectifier tube socket where the power cord and the dial lamp solder onto. And by the way, I got rid of that old white power cord and found a brown one that looks better on this. Whoever did this didn't do a very good job. They left parts of the old strandy power cord sticking out. And that's how pyrotechnics take place, and we don't want none of that, so we're going to have to make doubly sure there's no little hairline strands sticking out of this terminal, and then we can solder everything back to it. And of course we tinned our power cord and our dial lamp socket just to prevent any little strandies from sticking out during the connection and solder process. Alright, there we go. Everything's soldered in place and nothing's shorting out to anything. Okay, I've replaced all the bad wiring on top that goes from the oscillator coil to the tuning capacitor, and then under the chassis to the 12SA7 oscillator and mixer tube. And of course this is the antenna coil. It looks to still have 2 of its original capacitors attached to it. And this is our second IF transformer, while the first IF is a standard topside mounted transformer with a shield can on it. And we have this wire going into our first IF transformer that needs attention. Unfortunately, in order to properly replace that, we're going to have to dismount the IF transformer from the chassis, and that's done by squeezing these little clips together, and it should come off the chassis at that point. And unfortunately, it doesn't seem like there's an easy way to get this apart. This retainer clip is riveted to the can of the transformer. And it's funny that the rest of these wires look like they're holding up okay. It seems like the blue and green ones are the ones that's crumbling. I wonder if it had something to do with the dye that they used in the insulation. So I'm just going to run some heat shrink tubing down over this and fix it that way. Okay, there we are fixed up, and I ran the heat shrink tubing as far down into the transformer as I could, and that should minimize the chances of anything shorting out. Okay, we're about to the point where I can run the initial smoke test, and then if it passes that test, we'll go ahead and change these two capacitors out. And we're plugged into our isolated power supply. We're going to bring it up slowly here. You know, already seeing a little bulb illumination. We'll let it sit at about 60 volts for a few minutes and see what it does, although I don't anticipate any pyrotechnics. Alright, that's good. Let's see if I get any reception.
And it was going to be Bernie Sanders against Donald Trump, and the market was like 29,000. What? Always give me here for you. Sports will be back eventually. In the meantime, Bobby, we're good.
We're good.
Things change, and they change really quick. The type of change in the NFL. The Patriots been able to pull one move and get one wide. Would they have been able to?
Parts of the country, and that's, you know, why I asked Sam and Vince what is.
Yeah, when I turn it all the way up, it just overloads and distorts and goes away. So we're going to have to look into that.
These pictures, I haven't seen in person, but
And looking at this volume control and off-on switch, I think it's been replaced before. The shaft feels like it's been sawed off. And you can see where it looks like it's been pried apart. And it's generally not common to find a pull-on volume knob on an old radio from this era, so I suspect this is probably something that somebody pulled out of an old TV and made it work in here. Who knows if it's even the right value of control or not. Okay, as it turns out, this Aerovox capacitor is a replacement, but it checks just fine. It's the AVC bypass cap, so I'm going to put it back in there. The only cap I see that looks original is this .005 here that looks like one of those horrible RCA capacitors that like to open up at the ends. That's the antenna isolation cap. So we will replace that, but we'll leave this one. We'll connect this one back up, and yeah, they just had it laying over the terminal and soldered. We'll do a better job of that. Alright, I'll replace that antenna isolation capacitor with a safety cap just to be on the safe side. And the radio works pretty good. I still need to patch a couple of places in the speaker that I missed, but when we turn it up too high, it just overloads and distorts. Now, as I was pulling tubes out so I could get to that wiring to replace it, I noticed someone had written weak on the 12SQ7, so let's check a few voltages and see what we've got. The schematic says I should see 40 volts on the plate of the 12SQ7, and let's see what's there. I'm reading 57. It's a little high.
On the victory. And you know, one of the reasons I know they're blind is they don't ever come out and say,
tube, cathode,
you know, go find a man driving up here in a big black Cadillac or Lincoln Continental, you know. I stayed in the home last week with a fella. He said he had 2 Fords. I got up, had a house,
no
and had
there,
a special apartment in it, you know. I mean, everything for living, you know, in connection with my
96 on the screen.
It's amazing the homes I get to stay in.
Plate.
And but anyhow, I stayed
in
there.
89.
He got up
Let's see
next
what
morning.
the schematic wants
he said,
to see.
take the big.
Looks like 90 on the screen and 75 on the plate. So yeah, a little bit off there. Alright, I'm checking the control grid of the output tube and with respect to the cathode, and I'm getting -6 volts, so that tells us this capacitor, this coupling capacitor, is just fine. Here's the 12SQ7 that's supposedly weak. The schematic calls for 40 volts on the plate. We're seeing about 57, which is a higher than normal plate voltage, is often indicative of a weak tube because the tube is not drawing enough current, therefore not placing the normal load on the power supply of the radio, and therefore you have higher than normal B+ voltage. Well, just for fun, let's put this on the tube tester and see how it checks. Here's the triode section. It's not too terribly bad. It's not as good as a new tube, but it's still very much so usable. No excessive grid emission, aka gas. No shorts. Let's check the diode section. Diode section 1. Yeah, it's a bit weak. And diode section 2. Yeah, we'll round up another one just to see, but I think this tube is still usable. Okay, I'm checking this 10 meg resistor. It's the grid bias resistor for the 12SQ7, brown, black, blue, and it looks to have been replaced before. It's up to 14 megs, so that's it's out of tolerance, so let's replace it and see if that takes care of our overloading problem. And if it doesn't, I'll dig around and try to find another 12SQ7, but I think the one that's in there is still usable. Okay, I didn't have a 10, so I just took a 6.8 and a 2.7, connected them in series, and that got us close enough to 10, so let's try it and see if the overload goes away.
The only thing is this, who's going to...
Well, that helped.
Okay, alright. So you don't have a wedding, and you don't have a lot of money for a ring.
The pot needs to be cleaned. Well, just to go over what brands of capacitors I found in here that were replaced decades ago. The AC capacitor was an Aerovox Aerolite. These two silver capacitors that remain are solar Solite capacitors. And this capacitor here that connects the plate of the 12SQ7 to the grid of the 50C5 is a Sprague vitamin Q. This filter capacitor is a Sprague atom. And the AVC bypass capacitor is an Aerovox. Now, I'm not really up on my condenser ages, or capacitor ages if you prefer, but I'd say this Aerovox one here is probably from the no newer than the late 40s, early 50s, and these others I'd say are probably from the 50s, maybe early 60s. This filter capacitor I believe is from the mid 60s, but I'm sure all of this was replaced at the same time, but who knows how old these other capacitors were when they were actually installed in the radio. Okay, we're getting ready to align the radio, and we have our old triplet signal generator warmed up and ready to go. And we're connected to the radio, and I can already tell the IF is out of alignment. It's supposed to be peaked at 455 kilocycles, but when dialing our generator, we get our peak at about 440 kilocycles, so we need to peak out these tremors, and we're going to use our no-no tool here, our metal screwdriver, which I found that they don't really interact with these type of IF transformers as much as they do with others. The biggest thing you have to worry about with using a metal tool on these is sometimes the trimmers are hot, and if your metal tool comes in contact with this can while adjusting the trimmer, then you could have some sparklage. Okay, I'm now set to 455, and to further prove that we're out of alignment, so we'll keep it right there on 455, keep our output low. We'll adjust each one of the 4 trimmers on the 2 IF transformers for maximum output, and then as it gets louder, we'll decrease our signal generator output to prevent the AGC circuit from, or excuse me, AVC circuit to be more precise, from kicking in. Oh yes, and we are plugged into the isolation transformer. When you're dealing with a hot chassis radio such as this one, it's a good idea to plug it into an isolation transformer for safety, especially when you have external test equipment connected to it. Okay, let's turn on the second one, second IF, softer, so we want to go the other way. Okay, that's about peaked out on that one. Let's move over to the next. And this one's a little hard to get to with this tuning condenser mounting bolt in the way. Alright, that was a little off, but not much. Now this is the one I'm concerned with. Let's see. Oh yes. Okay, now let's do the next one here. Oh yeah. Now let's turn the output down, and we're going to repeat the process. Okay. Okay, that's that one peaked out again. That one. So the IF transformers are peaked out for maximum. And on the signal generator you can see, or hear, when we deviate off of 455, the signal, the modulation goes away. Before, maximum was down here around 440. And now they want us to connect the generator through a 100 picofarad capacitor to the antenna input, set the dial to the top end of its range, which happens to be 1720 kilocycles, and then set the generator to the same frequency. And that's about 1720, and then we'll adjust our oscillator trimmer for maximum, which is this trimmer right here. Come on, get in there. Let's crank our output down and now we set our signal generator and dial to about 1500 and adjust the antenna trimmer for maximum. Alright, there's our tone, and here's our antenna trimmer. About it right there, so this radio ought to be aligned. Turn our generator off, disconnect everything, and see how it does. Mind you, this is the only antenna we have, is just this little wire dangling out of the back of the radio.
Kid country reported more than 600 new deaths today, raising Stay safe. All right, we are the odd couple, Chris.
So Ally is deferring payment.
America is listening. At 601-693.
Hospitals are scrambling.
WSM, probably so. Okay, we're now on the longer piece of wire running outside, and it's really not any better with the long wire antenna than it is with the, we got a dial cord slipping. Sounds about normal.
Wife knew it too. It was like, yep. Shut down to confront.
We find ourselves thinking that
as many people as possible.
But this is about as sensitive as I would expect a little 5-tube radio to be. Alright, here we are back together. It could stand a new speaker, which it may get one day, but
but
it's working.
she will listen if I